from this one, and at 2 o'clock they start moving this one to north at 32 miles per hour, and this one east 26 miles per hour. And our problem asks how fast is the distance is increasing 4 hours after at 6 o'clock.
So, in order to find the distance between the chips at 6 a.m., we use the distance formula and we plug in our values. So A is 128 because after 4 hours this ship has moved 32 miles times 4, so it's 128. And this one is as well 26 times 4 plus the 200 miles that it had at the beginning. So our distance at 6 a.m. between the two ships is 329.85 miles. So the problem really asks how fast is the distance changing at 6 a.m. So in order to do that, we derive our distance formula to know how fast is the distance changing over time. The derivative helps because it's like how the distance is changing with respect of time. So now we derive our distance formula.
So we get that 2d equals 2a plus 2b, but we need to use the implicit differentiation. So it's 2d times the dt over dt equals 2a, the derivative of a, which is dA over dt, which is how fast is a changing in rate with respect of t, plus 2b times dB over dt.
So now we need to find our dt over dt, and we just substitute. So 2, we already have a d, which is 329.85 miles. D equals to a, we already have it, 128 times. This is how fast a is moving with respective time. So this is going to be 26, 32 miles per hour plus 2b, we already have it, which is 304 times. This is how fast b is going with respective time, which is 26 miles per hour.
So now we substitute our values and we solve for d over dt, and that's our result. It's 36.54 miles per hour, which is it means that at 6 a.m. the distance between the two ships